Assalamualaikum students. Today we are going to start our most important chapter, that is circles. It contains 7 marks of your board examination and it is the most interesting chapter. Before going forward, first I will make you understand what a circle is. Remember, a circle we define as the set of points which are equidistant from a common point. But remember, set of all points possess some property, that they are equidistant from a common point. Set of all points which are equidistant from this point, and this common point we call as the center of the circle. So I will complete the definition of the circle as set of all points equidistant from a point. But set of all points, we can use a single word apart from these 4 words, which we call in mathematics as the locus. You may be familiar with it. What is a locus? It is similar to locust, yeah, but the real meaning of the locus in mathematics is something very interesting. A locus means set of all points, but these are not all points always, but these points possess some property. It means if these points does not possess property, it is not the locus of points. So we may define a circle as the locus of the points, and which are equidistant from a common point. But remember this thing, the locus, these points must possess some property, and I have completed the definition as locus of points equidistant from the center. But remember, these points must possess a property. I will give you an example. These are the points I have shown here, but remember, these are not the locus because these doesn't possess any property. So we may not use locus in a circle. We can use the locus in a line segment also. For example, if A and B are 2 points and we have a relation between them as the locus of point is between A and B. So a line may also be defined as the locus of points. Hope students you have understood it very well, that what is a circle and what is the center and what is the locus and where we can use. Alhamdulillah. Students, after that I will go through the chapter where we should first know what is a tangent, what is a secant. For example, if we have a circle and I will draw 3 lines. First line, it doesn't touch the circle at any point. And the second line, it touches the circle at one point. We call this line as the tangent of the circle. And the point where it touches the circle is known as point of contact. After that, I will draw another line to this circle which touches the circle at 2 points, which we call as the secant. It means line which touches the circle at one point is called as tangent, and the line which touches the circle at 2 points is called a secant. For example, now students, remember the radius of the circle is always perpendicular to the tangent through point of contact. It means if I will draw a tangent and another tangent to a circle, remember the radius to the point of contact are always perpendicular to this. This is the first theorem. I will also give its proof inshallah. After that, we have a circle and we draw 2 tangents from a common point. Remember always, the tangents drawn from a common point to a circle are always equal. If I will draw the 2 tangents here, so remember these both tangents are equal. Hope students you have get it, and this is your second theorem, and inshallah I will give its proof also. Students, after that I will go through the exercise. Students, after the introduction, now I will go through the exercise. The first exercise is very simple. I will show you each and every question, and after that I will give the proof of the first theorem. Now here is the chapter, and now I will start the exercise. These are the some of the fill in the blanks always asked as MCQs in your board examinations. For example, students, I will write here as how the first question here. I have shown you at the bottom of the page how many tangents can a circle have. So remember, whenever we draw the tangents to a circle, these are always infinite. I am showing you here. I am just make a small circle. After that, I am showing you how many tangents I can draw. So the answer of the first question is infinite. Okay, students. After that, I will go to the question number 2. These are the fill in the blanks. A tangent to a circle intersects 18 dash points. I have told you before that a tangent always touches the circle at 1 point. It means, I will show you the graphically here, the tangent intersecting the circle at 1 point. Students, so the answer of the question number 2 part first is 1. Let me finish. I will write here 1. After that, we have second part, a line intersecting a circle in 2 points. This also I have shown you graphically that whenever a line which touches the circle at 2 points, which we called it as secant. Students, after that, I have the third part of the question number 2. Let me finish. The third part of the book is a circle can have dash parallel tangents at the most. Student, this is the most important thing you have to understand very carefully. For example, I will draw a tangent here, and remember, whenever I will draw a tangent, its parallel tangent comes its opposite. We know that what are parallel lines? Those lines which will never intersect, and the distance between the lines is always same. I will draw another tangent here, and this is the one parallel tangent. Now I can draw another also from the right and from the left. It means you have to understand very carefully. It means the maximum parallel tangents can be drawn to a circle as 2. I am showing you another tangent, but remember these are not parallel. It means the parallel tangents possess some property. It means a circle can have parallel tangents maximum as 2. It can't get more than 2. Remember this thing, students. Let me finish it, so I will make you understand fully. I am giving you the examples that it has only 2 tangents. Okay, students. After that, the last part is the common point of a tangent to a circle, and the circle is called, the point which is common to the circle is known as the point of contact. I have shown you also the graphically the point where the tangent touches the circle is known as the point of contact to that circle.
After that, we have done the first exercise.
Students, alhamdulillah, it is the completion of the first exercise, and after now I will show you the proof of the first theorem.
For example, if this is the circle, and for example, if this is the tangent AB, we have to prove that OB perpendicular AC. Students, in order to prove this theorem that the radius of the circle is perpendicular to the tangent through point of contact, I have to first make you understand something very different. For example, if we have 2 points and there is a person A, there is a person B. A person A wants to go to person B. He has a lot of areas where he will go. But if we will see, this is the smallest path because it is a perpendicular distance. Remember always, the smallest path between the 2 points or a point in the line is the perpendicular distance between them. Is the perpendicular distance between. Why I have said you this? Because it is being used in this theorem. For example, in the proof, I will write here, since OB is the radius and AC is the tangent through point B. Now take another point D on AC. हमने यहाँ पर एक पॉइंट ये लिया एंड ज्वाइन OD और इसको ज्वाइन किया OD के साथ. आप मुझे बोलिए OD बड़ा है या OB? It's common sense. OD is bigger than OB because OB is outside the circle, and a point which is outside the circle is always greater than the point on the circumference of the circle. It means OB is smaller than OD. It means OB is the smallest distance between the point O and the line AC. Hence, OB perpendicular AC. So you can write here OB is smaller than OD. ठीक? Then you have to write, you do yourself, then you have to write, it means OB is the smallest distance between the point O and the line AC. Hence, OB perpendicular AC. This was your first theorem, students, in which you have proved that the radius of a circle is always perpendicular to the tangent through point of contact. Alhamdulillah, our first site has completed and our first theorem has been completed. Inshallah, in our next lecture, I will show you the second theorem and the second exercise, inshallah. Assalamu alaikum.